Hello, today we're going to talk about groundwater. And there's a lot of similarities between groundwater and surface water in terms of what it takes to be efficient. We still want those marginal net benefits to be equal across all users. And if there's uneven availability over time, we have to have some mechanism such as prioritization of the water rights, pumping rights in this case, to achieve keeping those MNBs, marginal net benefits, equal over time with varying water quantity. Now, one of the interesting, maybe vexing things about groundwater is that initially, I have my graph, I'll show this to you, to how it works, how it looks in a model. Initially, a free-for-all is efficient, right? Initially, when groundwater resource is first tapped in, the good old law of capture works just fine because there's more than enough water. The only thing that's scarce is the resources to build the pumps, put them in the ground, and run them. All right, so here's my first graph and today's only graph. Okay, so we have this kind of a situation. Again, hopefully I can be heard even though my mouth is behind this piece of paper. All right, so we have a situation where we have demand D0 initially. And you can see there at point E where D0 intersects MSC and MPC. We have point E and Q star, the optimal, equals QE sub 0. It's hard to tell that that's an E right there above my fingernail. That's an E, which just means that before the marginal social cost and the marginal private cost bifurcate, which means separate, so we professors have to use big long words every now and then. Okay, so up to the point where they separate, that's a sustainable amount to have, and there aren't any externalities or any of that. Remember, MSC greater than MPC means there's an externality. But up to a point, up till demand gets to a little past D0, there's no problem. The level of pumping that will occur based on the cost of pumping, that would be the marginal private cost, and the value of the water represented by D0 yields a sustainable pumping level. Okay, so the vexing, challenging, interesting aspect of groundwater is that always happens. In other words, we always get an entrenched situation where people are used to having to pay for nothing other than running their pumps. And that works just fine. And all the economic relationships between businesses that directly or indirectly depend on water use get fixed or set in concrete, if you will, based on that practice. And then suddenly, as indeed started to happen here in the San Antonio area in the 1980s, with increased growth, okay, increasing demand past point E out, say, to demand level D1. With increased growth, now there is an externality. Now the equilibrium level of pumping, which would be represented by point C, which yields QE sub 1, right there, okay, above my fingernail. We have an externality in that there are one or both things going on. At that level of pumping, we are either drawing down the resource. The externality then would be higher pumping costs, less groundwater availability in the future as a result of current pumping, or there's crowding going on. Namely, there are so many wells that the pumping by one well is undermining or interfering or increasing the costs of pumping by other nearby wells. Okay, so crowding is an issue in MSC greater than MPC, and drawdown, namely tapping it faster than Mother Nature is replenishing the water, is another potential issue. All right, so that's what's going on here. And the challenge is, once you get past demand D0, is to have a management regime. And it's going to sound familiar. It's going to sound like a broken record. You might even be going, yeah. There goes Merrifield, same old list of menu options. That's why I told you when we were going through that stuff about dealing with pollution, right, all that 1, 2, and 3A, 3B, 3C, all that stuff, that we would be using that over and over again. And that's why it was so important to understand how those different options worked. So, among other things, what could we do here? Well, we could have a tax on the extraction of water. That would be sort of like your most environmentally offensive input kind of a tax. We could have a tax on the end users of the water. That would be like a tax on the output of the polluters would be analogous to that. This graph doesn't help inform how big those taxes should be, because here we have the demand and the supply of water, not the end uses of water, not a most environmentally offensive, or in this case, a most natural resource depleting offensive input, namely the water itself. Here what we have is just the water. Okay? It'd be analogous to your pollution abatement graph and looking directly at the issue at hand, namely the water use. All right, so in this case, what would be the direct approaches, right? The ones that I just listed would be the standard indirect approach. The direct approach would be a pumping fee. Okay, how big should the pumping fee be? The difference between A and B should be the pumping fee, because we want to move the equilibrium to the optimum. We want the MSC and the MPC to be equal at Q1 star, right? What's Q1 star? Right there, right above my fingernail. Okay, so if we don't do that, we're going to have a dead weight loss out here at QE1, right? The dead weight loss would be area BFC. Okay, BFC is the dead weight loss if we don't do anything. And I'm not sure if you can see where I very faintly drew this line up here, my middle finger up here on the y-axis. You can see up there, and there's a point G on it. See, if we pump at point C, quantity QE1, probably there's a drawdown externality. And as a result of the drawdown, the marginal social cost and the marginal private cost will shift over time from here up to here until we're at a point like G, okay, or a point that I didn't label because I didn't want to get this graph too crowded looking. This point right there, okay, below my where the D1 hits that kind of faint looking line. Okay, so the drawdown by pumping QE1 in the current D1 time period will gradually result in the MSC MPC line shifting up and leftward from here up to there. Okay, and G would be your point at which an externality sets in. And notice the way I've drawn point G, it's a little bit, it's hard to tell, it's a little bit to the left of point E, which just says if you draw down the water resource, right, pump too much so that the water table goes down, what you might be doing is reducing the level of pumpage that's sustainable, right? In some aquifers, that happens because by drawing down the water table, the overlying strata of material compact downward and make it harder to access the water. Okay, so G, right up here, okay, is a little bit with a smaller quantity than point E to illustrate that it is likely, indeed possible, that with drawdown, pumping QE1 in time period 1, it gradually will reduce the sustainable level of output. And then if we do decide to do something late, okay, in other words, if we wait till the resource draws itself down quite a bit, right, till the pumping costs are higher because the water table is lower, then if we want to return to this more natural situation, okay, then we're going to have a period of austerity. What does that mean? That means a period during which we take less water than even the smaller new sustainable amount, right? So for example, G is the sustainable level if we're way up here, right, with marginal social cost, private cost way to the left of where my big bold lines where I've drawn it there. Okay, so then to shift that line back down again, okay, then we have to actually pump less than the quantity at point G to have the water table rise and have the marginal social cost and marginal pumping cost fall back over time until it reaches a desirable level, say the existing level that I drew on there. All right, so one of the ways to do that, okay, would be to institute a pumping fee, okay, equal to line AB. Now, you can see that that still leaves Q1 star at a level that's not sustainable. What does that mean? That just means that this MSC MPC outward shift before sustainability is reached is going to be smaller than it otherwise would. What does demand D1 mean? It means that the demand is so high that it's actually worth drawing down the resource for a while. That water in the present is so valuable that it's worth taking away some water from the future. Okay, but only the level at Q1 star, right there where my wiggling finger, index finger on my left hand is pointing. Okay, Q1 star is optimal during time period 1. QE1 is not. QE1 yields dead weight loss, BFC or CBF, depending on which order you want to put those three letters. ABC is not your dead weight loss. AB is the emissions fee that you want to have if that's the policy you choose. What if you decide to have emission allowances? Okay, well, they're not emission allowances anymore, but the analogy to that, a pumping quota, okay, a total amount of allowable pumping. Well, how much would you do? Well, at first you'd start off with Q1 star, and then probably you would phase that down a little bit, not necessarily all the way down to Q0 star, because at Q1 star you are going to draw down the resource a little bit, so the amount of pump might ultimately be a little bit more or a little bit less than Q star, because what D1 is telling you is that water is so valuable in the present, it might be worth drawing down the resource and at some point jumping to some other water source, another aquifer, or maybe a surface water source. Okay, but you would start off, if you had emission allowance equivalent, which would mean a pumping quota where the water rights are divisible and tradable, make sure those MMBs get equal. Q1 star is the amount that you would initially have to make that work. Okay, and then because that's not sustainable long term, because that'll still yield quite a shift in the MSC lines, you might want to phase that down. And indeed, because it's difficult to auction off something that people thought they already owned, you probably have to start these water rights off at historical usage levels, plus perhaps on top of that some correlative rights. Remember the correlative rights from the last video? That means that landowners may not have exercised their rights to pump or to divert water in the case of surface water, but it is assumed to be part of a property right. And so to avoid having litigation and or just more political power struggle than you care to have, you might need to grant some water rights to the individuals that claim correlative rights, just to pull off the starting of the water market by issuing those tradable pumping allowances in the case of groundwater, or tradable diversion allowances in the case of the surface water. So again, what would that mean? That would mean probably issuing even more initially than Q1 star, and then having some device to phase down Q1 star to a smaller level, perhaps all the way down to Q star, maybe a little bit more than that, maybe a little bit less than that, depending on how much you wanted to draw down the water in the present to possibly make a transition to another water source later, or just have this water source be at a lower sustainable level because water is so valuable in the present. All right, so I think that's gotten us off to a good start, and I don't want to flash this graph too many times. I think we've kind of beaten it to death. Let me review all of it just one more time. Up to demand level D0 and perhaps a little teensy-weensy bit past point E, we have sustainable use just as a natural consequence of people pumping all the water that they want out from underneath their own property. But when demand shifts further to the right past D0 to a situation like D1, now what's worked forever in terms of efficiency, in terms of people exercising correlative rights with land, namely you buy land, you expect to be able to pump water from underneath it. Now that process is no longer efficient because it yields an equilibrium like C, when an equilibrium like B would be more efficient. To move from C to B, you can have either saleable pumping allowances, analogous to saleable emission allowances, or you can have a pumping fee equal to line segment AB to achieve that efficiency in the short run, and perhaps a phase down of the pumping rights to a smaller quantity, and or a phase upward in the size of the pumping fee to achieve a little bit more sustainable level. And ultimately you have to achieve some sort of a steady state with Mother Nature pouring water in and you sucking water out. But it doesn't necessarily have to be at a level like point E. It can be either smaller or larger than that, depending on a lot of other variables that we won't get into for this class. And you could build a whole course around surface water and or groundwater management. And we only have today, actually in class today, and then we're going to move on to fisheries. And I actually might throw this graph up a little bit again when we start into fisheries, because it's actually exactly the same situation. Notice that I didn't label it at the top. So see, I left myself room to reuse this graph, because fisheries is the same thing. Up to a point like E and a little bit beyond, fishermen, fisherwomen, fishers, as they're called politically correctly, can go out and take all the fish out of the lake or the ocean that they can catch, given these marginal private costs of catching fish. And that can be done sustainably until demand increases past D1. And thus, now the normal course of events with people just fishing to whatever level they would like to based on fishing costs, okay, running the boat, hiring a crew, fuel for the boat, all that. That's no longer a high enough cost to keep fishing within sustainable levels. And so then you need saleable fishing rights, and you need perhaps instead of that, perhaps a saleable fishing fee. Okay, I probably said a little bit too much about that, but all right. Well, it's all going to be on the same exam, so we'll get back to that after I do a second set of stuff on this groundwater to finish that off. All right, so I'll be doing that in a couple minutes, and I don't know whether you're going to watch it now in a couple minutes or watch it later. Certainly, we do want to have a discussion of it on the online forum and or in class. See you shortly.